We'll have a look at the example 2 here, which talks about calculating our angle of Loll. Okay, so with a box-shaped vessel, we're given our kg measurements of the box shape and we're in salt water. We need to calculate the angle of Loll if we load 500 tons at kg8. Well, first obvious thing to do is find your initial displacement, length into breadth into draft times density, 4705, kg given 3.7, let's add the cargo, kg8, calculate your final kg, 4.113. Sometimes when you're doing stability problems, or often when you do them, it's obviously you look at the formula that you have to use to solve the problem. And it tells us that tan theta, the angle of Loll, is minus 2 times gm over bm. Okay, well how do we get gm? Well, gm is km minus kg. And how do we get bm? Well, bm is km minus kb. So if I perhaps did just a very rough sketch here. There's the keel, centre of buoyancy, centre of gravity, metacentre. Gm, G to M. Now we've got the kg, so if we can find the km, we can find the gm. To find the km, we need the kb and the bm. Bm there is required in this formula. Okay. Well, to find the kb, we need our new draft, and kb is simply half of the draft of the vessel. We know our final weight, and we know the length and the breadth of the vessel, and we know the density of the water. So putting everything together and moving the form around, we can find the new draft of the vessel. So the draft initially was 5.1, after loading it's now 5.642. So kb is simply half that, 2.821. As the previous example tells you, to find bm, it's simply b squared over 12d. Breadth is 9, so that's 9 squared over 12 times our new draft. Now of course you must use the new draft because we've loaded cargo, and gives us a bm of 1.196. km is kb plus bm. kb plus bm. 2.821 plus 1.196. So our km is 4.017. kg 4.113 that we've calculated in the example. And you'll notice straight away now that G is actually above M. So in my sketch here I should put G really above M. And it means of course that it's negative. So GM is minus 0.096. So we've got our value for GM. And BM of course we've already worked that out is 1.196. So putting them in the formula, minus 2 times minus 0.096 obviously makes it positive. And it gives us an angle of Loll of 21.8 degrees. So I've done a rough sketch here just to sort of perhaps explain what we've done here with the actual curve itself. So negative GM initially is 0.096. And there's our curve starting off negative. So our GM is negative, and when we draw the tangent, 57.3.096. Then as the vessel heels over, at some point the water plane area will change. This isn't something that you need to get too involved in, but that changes and the metacentre will change and the vessel will settle at this angle of Loll. And we've calculated that at 21.8 degrees that will be the angle of Loll for the vessel, and she'll settle at that angle. And that's how we solve that particular one. Now let's move on to the next example, and it talks about the metacentric height, or the GM, at the angle of Loll. If a vessel rolls beyond the angle of Loll, if we look at our sketch here now, if our vessel is settled at this angle, if it actually rolls, angle of heel increases, then this is the GZ value here, then it actually has a righting lever. Originally these were capsizing levers, but now all of a sudden we do have a righting lever. And to have a righting lever you must have a positive GM. And as we can see with the curve here, this becomes positive. So at the angle of Loll, our GM actually becomes positive. So let's have a look how we calculate that. We simply use a formula which says minus 2 times the initial GM over cos theta, and theta has to be the angle of Loll. So here we have an example. Box-shaped vessel has a km, kg, bm. Calculate the angle of Loll and the GM at the angle of Loll. Very straightforward formula, works out the angle of Loll of 20, and at that 20 degrees our GM would be 0.21. We could have used that formula on our previous example, because we've got the GM and we've got the angle of Loll that we've calculated, and of course we've got the information there that we need to work out the GM at the angle of Loll. So working out the GM at an angle of Loll is very straightforward. And of course working out the angle of Loll really is reasonably straightforward. But hopefully the sketch that I've done there, that sketch just explains it when you're used to looking at the GZ curves. So angle of Loll obviously negative, GM initially, settle at that angle, and our GM must be positive then, because we do actually create a righting lever if we heel over any further than the angle that we've got there.